Hello and thanks for joining. My name is Liam Conway and I have the pleasure this week of being the editor. I'm joined by two businesses, Premier Patterns and Castings and also Agemaspark. We're going to be looking at some recent news that both of these companies put out on the website. So we're going to be looking at Premier Patterns and Castings celebrate 25 years, and also engineering company seals a deal to complete extensive trial using 3D metal printing technology. So if I jump straight into it, so Andrew, I'm going to come to you first. So one of your recent investments was in a CNC robot arm 7-axis machine. Could you talk us through why you invested in that machine and how you think it will enable you to expand your services?
Hi, Liam. We originally invested in a large gantry milling machine, CNC, but workload proved that we could have done with two of these machines, but we had no room really in our workshop. So we looked at what was on the market, and we looked at this robot arm and found out that it could do everything and more, albeit the envelope was a lot smaller. So we invested in this robot arm to cut small to medium jobs, where our gantry miller could put 5 meters by 2.5 by a meter. That was we call that large jobs, and so they complement each other, albeit the robot arm can do a lot more, being 7-axis. At the time we had lots of sculpture work, which proved to be the robot proved to be like a lot better than the gantry miller, because the gantry miller is a 3+2 axis, and the robot arm 7-axis, including the rotary table. So I don't know if you can see this here. This is a busk. We had a lot of these to do. This is a 3D.
I think it's just temporarily cut off. You're still there, aren't you, Paul?
Yes, yeah, I can see you. Yeah.
Well, I tell you what, I will use my initiative and I will improvise here, and I will come to you, Paul. And if Andrew rejoins us, then I'll go back to him if that's okay.
Yeah, absolutely fine.
So, so your article talked about a new and pioneering 3D metal printing technique. So that sounds pretty impressive, and it's resulting in major reductions in cycle times for multi-impression mold tools. So improving the efficiency by as much as 20%. Brilliant. Can you tell us how you achieved this and what inspired you to develop the new technique in the first place?
Yes. Gosh, some 17 years ago, I was invited to look at some new technology, which was laser deposition welding, which was additive manufacturing powder and a single stream laser beam, which could weld complex shapes onto metals. As part of a project that I was involved with the TWI, the Welding Institute, and Rolls-Royce to develop a technique to repair seal segments on aircraft engines. These are the segments that fit on the outside of the engine casing, where the blades come in contact with what's called a honeycomb wear part of the engine. So it was a technique that we spent 3 years developing that with lots of TWI and that for Rolls-Royce. And it kind of inspired me that 20 micron grain of metal powder could be welded together by laser, and the technique was very successful. So we ended up. This is now a recognised repair to turbine engines in all of Rolls' aircraft engine set. And that set me on a road to looking further into this kind of advanced additive manufacturing kind of technology. And at that time, it wasn't readily known about between the population. It was fairly kind of sort of situated right in the aerospace industry and the military side of things. But as this kind of progressed, I came across the other techniques of being able to use powder additive manufacturing to produce complex shapes, which was the powder bed capabilities, i.e. a layer of powder and it layers and welds and builds up a series of internal and external shapes to produce parts. Now, over the years, I think people become more aware of 3D, that you can do more so that in producing plastic parts, and probably they've seen a lot of this in the media and things like that. But the metal side of printing was always kind of set within the aerospace industries and to some degree, I think sort of kind of Formula One picked up on things like that as well. So over that time, but I looked at this because we work with a lot of caps and closure companies, the people who make the milk bottle tops and the drink bottle tops and various things like that, along with lots of other injection molding kind of companies as well. But predominantly, this is a single-use, high-volume plastic part that's they kind of they'll kill for a nanosecond of time saving and things like that because of the known quantities that they have. Now, at that time, there wasn't such a problem about single-use plastics when I kind of discovered this maybe a better part of 8-9 years ago on this particular technique. And but as far as I can say that I saw things in there that I could do with this to reduce the size of the actual metal parts that are required to put water cooling within the component. Things you could only dream about. It was not really you just couldn't get to those kind of shapes inside of it. Literally you just could only drill a hole. So it was for me, it kind of made sense that if I could take a component to produce a small cap with a core that's probably its base size is about 80 millimeters diameter, and fetch it down to something that's 30 millimeter diameter, but producing the same component, much reduced. In essence, what I concluded that I could put, for example, the standard cap tools are about a 32 impression. In fact, you could nearly take that 32 impression mold, same envelope, and put 64 on the same thing, because you can reduce the size of the required insert, because you will conventionally looking at trying to put a drilled hole into it and trying to feed to it. Whereas with the conformal cooling technology, you can build internal spirals that are wrap around the actual molding surface within a few millimeters, and producing the actual thing about reducing cycle times and things like that actually wasn't in the mindset at that time. It was literally the fact that we could increase a cavitation by 100% effectively. That became a little bit of a problem. A lot of people decide they don't like to change convention, and they need proof. Was basically a lot of the problems I had at that time. So, I had more and more I looked into this, and the more and more I thought about it, it was going to be a pretty sort of a revolution. It isn't that it's not out there already. The Germans and the Central European countries there have been doing this for some time, and they've kept it pretty much in their borders as much as anything, and it's not really going to come out across the North Sea yet. So, but I think in essence it was one of my ambitions then to prove we could make this technology be useful. So I can't hear you, Liam.
Sorry. I think you've talked about the fact that it has led to shorter cycle times, but that was sort of a happy byproduct. That wasn't the primary driver. But was there anything else that you sort of?
Well, yeah. Initially, I guess initially that the original one was kind of we can make more of what you want in a better time cycle and everything else. But as you develop that, I decided to invest in producing a tool of my own to really back up all my thoughts and everything else that I thought this what I knew to be good. So I got a UK Innovative grant, and we produced a 2-impression tool, and we built all the conformal cooling requirements within that tool to test a sports drinks cap top, basically, which is one of the these people. I mean, in a single company local to me, they make sort of 2.5 million of these sports drinks caps every week, and they make something like 6 million milk bottle tops a week. So it's a huge amount. That's one company in the whole of the UK. So the huge number of these products in an annual life cycle, that there's billions of them effectively. And at that point, a lot of the issues now start to become about global warming and plastics and the dangers and things of that nature that were coming into play. And I built this tool over a year, and we put it through independent trials at Bradford University, and we had a lot of data recorded of thermal imaging and cycle times and everything else. And what came out of that was the fact that we could prove categorically that we could reduce the cycle time by up to 20%, if not more. But also, again, when you started to looking at other things, the requirement for large mold tools with lots of big plates supplying water to inserts, effectively what we discovered also is that the conformal cooling, we did not put any more water in there apart from feeding directly into the inserts. And we discovered that a small dust cover cap, literally the heat transfer was no bigger than a cricket ball. And it stayed constantly like that for 2 or 3 hours that the mold was running. And it just went on and didn't change. The environment never changed. So we weren't looking at heating huge quantities of steel. We could literally fetch it down to a few liters of water to control a mold tool instead of tens of thousands of liters in the cycle time within a mold shop. Yeah. So that was one of the things. So the next thing that kind of came into my head there was the way this technology can be developed is that we can prove now that we can create it at 20%, and then you kind of start to investigate what 20% means. So in theory, the technique of 3D metal printing is probably 10,000 times less energy use than a steelworks producing massive chunks of steel where you have to turn it to swarf and create. So the manufacturing of the actual mold itself now becomes much more ecologically sound as a proposition that you can design and build tools that don't need to be 1 meter cube. You can make them much smaller because you can reduce the necessary requirement of feeding water. So energy-wise, you're starting to reduce the size of the tooling. Effectively, then you can reduce the size of the press that you use. So not only does 20% reduction in cycle time become a added advantage to the manufacturer, it also has a 20% reduction in the use of energy to produce the same quantity of the parts that you want to make. So the value of that now starts to rise as an accumulative different levels of consequential issues about just using this technology. So the fact that single-use plastics have a pretty bad name, and we are finding ways to try and reduce all of those things. The fact that the new technology and the fact that people will start to develop new polymers that are biodegradable and want to be the thing that we want to be using, because without doubt we're not going to get away from using plastics or single-use plastics for some time. But in that meantime, we need to kind of find a ways of making it more A, efficiently, and B, less environmentally damaging. So if you kind of think the deep parts of all that, you can make this quite a reasonably ecological solution or a partial solution to help reduce the global necessity for generating huge power supplies to manufacture the parts, tooling, and also in production we can reduce it by various methods to reduce that impact as well. So I think it kind of evolved into some form of people need to kind of consider this technology as a future one in the design and manufacturing of the tools themselves to help create that kind of environment. Secondly, the payback of that for the company producing the parts is that they have some kind of, in inverted commas, green credentials, as in to try and help. But as things develop over the next, well, I assume they're developing now because they're looking for biodegradable plastics and everything else. But somewhere along the line, processes to produce these things may require different ways of doing it. And this is one of probably a few different ways of helping them get to where they want to be, so it can be actually a practical solution to making parts. But again, it also, the 3D metal printing opens up so much more in the way you can produce molds as well. So we've found techniques now that way we can create as I put it, I think it's a bit like the electrical scenario, which is a halfway house where you've got petrol and diesel, you've got hybrid, and then you've got pure electric, where if we take a mold tool that exists already, we can actually take the top off the part that's creating the component and sinter conformal tooling on top of what already exists. So you can slice the head off and build a new head if you like, but incorporate conformal tooling, which then will give them a better way to produce the product. So there's kind of a lot, I think, that this technique will be able to offer, certainly in the future. We've been doing trials with a company making caps and closures, and we've run some new caps in there using 3D conformal cooling inserts, and the numbers are quite ridiculous when you think about it. But in a conventional cooling tool, if you were going to cool it conventionally with just drilled holes and things, the cycle times were somewhere between 5 and 6 seconds. That's with conventional. With the conformal cooling, we've actually got it down to 3.2 to for 3.5 seconds. So, and it's kind of proven the 20% plus is actually achievable.
Yeah.
So then the conversion of that is if you run a tool of that, a 32 impression or something of that nature in them conditions for 12 months with the number of parts that they make, on average, you could probably save or make anything up to £500,000 on that, just by that 1 second of cycle time change. So, we've actually done some financial equations with actual figures, that has proven to be, it's just slightly short of 19.8 something, I think, percent. So, but that's sort of straight on your bottom line. It's also, they will save 20% more, less energy to produce. So yeah, I think that's the kind of,
Good.
I'm a good believer of this, and I hope a lot of people want to get involved with it. So.
Super. So Andrew, last time we were speaking to you, you were holding up your your thing. So shall I jump back to you?
Yeah. What it was, I was trying to point out how different the gantry miller was to the new robot arm. The gantry miller is like a 3+2 axis, but the robot arm is a 7 axis. So this is a bust, 3D printed. But if you go life size, scan it up and go life size, we cut any size, but say life size. What happens with the robot arm is just the cutter comes in and the rotary table rotates, so you can get every little detail. So it was a good investment to for the point of view making sculptures and shop designs and theatre and film props, or something like that. So it gave us an extra scope to go down different services.
Great.
So it's proven a good investment.
Excellent.
Yeah.
So the article, it seems that you operate across a fairly broad range of sectors. So is that sort of diversification something you've purposely focused on historically?
No, it became a natural process, really. 90% of our work when we started back in '96 and for years after was we're making patterns for the press tool automotive industry. And we'd make these patterns for Ford, Honda, and the local tool makers, or the UK tool makers. But over the years, they've found a cheaper way to get these castings made by sending them abroad to Spain and Italy, particularly Spain. So we have to offer our services elsewhere to keep going, and it's been enjoyable, working in different sectors, but you have to diversify and go down different avenues to survive all these years, something new we take it on and become experts at making them, and then it's another sector we're involved in. So we've collected a lot of sectors over the years and services. Yeah. So.
And I know there was a note that came around after I was going to ask this question, so I think your view might have changed on this, but I think it'd be good to talk about. So you mentioned that export orders were sort of holding up well, and lots of business and clients that we speak to have faced challenges. I just wondered how you saw that moving forward post Brexit.
Well, since the article, it seems the doors have been closed at the minute, as far as Europe's concerned. We've dealt with Europe for 10 years now, making some CNC parts for them. The one in particular was a French customer. We gave them a quotation, that the price that they're used to. As you follow up the quotation, his reply came back that they're keeping it in their country to help their economy.
Right.
So I think it's something that we should be doing as in the UK, you know. But like I say, when we first started, it all used to be kept in the UK, but people went after cheaper prices. I don't know how Spain can make patterns and castings cheaper than someone round the corner, you know.
Yeah.
Round the corner in the UK. So I suppose there's questions to be asked there. But that's
Yeah,
another-
well, I think we've seen examples of reshoring, and if we can get more of that, then fantastic.
Yeah. But we keep knocking on the doors, and that's what we do. Try and get some work out of Europe.
Yeah.
If there's work there. Well,
Good.
but mainly we want the work out the UK. We'd like to do the work. We're still here. The work that we used to do, we can still do. And 10% of that work, the 90% that we started with, we still do, you know, for local tool makers, UK tool makers. But the trend is to send the designs abroad and get the patterns made abroad and cast them. So hence we've gone down different avenues and different sectors and services to keep us going, because diversity is the key, I think.
Yeah.
Mm.
So for any Made in the Midlands or Made in Yorkshire members, you're open for business and looking to help them.
Yeah, certainly.
Good. Okay. Thanks both for joining. Join us in 4 weeks for another episode of the Editor's Pick. Bye.
Thank you, Paul.